Alright, so we're doing linear equations and inequalities. So an equation would be something with a big fat equal sign in the middle of it, and normally we're going to have to solve for a particular variable. And the inequality is when we have somewhere in less than or equal to type thing going on. Alright, so let's do our first example where we're going to talk about 8x minus 3 times x minus 4 equals to 3 times x minus 4 plus 6, and we want to solve for x. So the first thing we're going to do is distribute into the parentheses on the left hand and on the right hand side. Remember, so we have minus 3 times x minus 4, so we got to distribute a negative 3 into x and negative 4. So we're going to get 8x minus 3x, and then minus 3 times negative 4 equals a positive 12, equals to 3x minus 12 plus 6. We can combine like terms on both sides of our equation. So 8x minus 3x, we're going to get 5x plus 12 equals to 3x minus 6, because minus 12 plus 6 equals minus 6. Now we can subtract 3x to both sides of our equation, and we're going to get 2x plus 12 equals to minus 6. We can subtract both 12 from both sides, and we're going to get 2x equals to minus 18. Then we can divide both sides of our equation by 2. We're going to get x equals to minus 9. So that is one example where we have like x solving for a particular number. But what if we have our entire equations expressed in terms of variables? So like what if we have a equals to p plus prt, where this is the equation for simple interest that we're going to be using later in the semester. So we don't have any numbers in the equation, but we still want to solve for a particular variable. So for the first example, let's solve for r, the rate variable. So if a equals to p plus prt, we're going to want to get the term that contains the r variable all by itself on that right-hand side of the equation. So to do that, we're going to subtract p to both sides of the equation. So a minus p equals to prt. We can now divide both sides of our equation by what we're multiplying r by. We're multiplying r by pt. So we're going to divide both sides of our equation by pt. And then that's what we're going to end up with. A minus p divided by pt equals the variable r. Let's do another example where we want to solve for p. Remember, we still have a equals to p plus prt, but this time we're going to want to solve for the variable p. So on that right-hand side of the equation, we have two different terms that both contain a p. So we're going to need to factor out that p on the right-hand side. So we're going to a equals to p times 1 plus rt. So now on the right-hand side of the equation, we have p times this thing. So we can divide both sides of the equation by that thing, and that will solve for p. So we divide both sides of our equation by 1 plus rt. 1, let's put that in parentheses to make it a little clearer, 1 plus rt. So we're going to get a divided by 1 plus rt equals to p. And that's how we can solve for p. So let's deal with some inequality type examples. So if we have 2 times 2x plus 3 is less than 6 times x minus 2 plus 10. Well, the first thing that we're going to want to do is distribute into the parentheses. So we're going to get 4x plus 6 is less than 6x minus 12 plus 10. We can combine like terms on that right hand side of the equation. So 4x plus 6 is less than 6x minus 2. We can subtract 6x to both sides. So we got minus 2x plus 6 and less than negative 2. We can then subtract 6 from both sides of the equation. We're going to be left with minus 2x is less than minus 8. So we can divide both sides by negative 2. Now remember, when we divide or multiply to an inequality by a negative number, we're going to have to flip the inequality symbol. So we're going to be left with x is greater than positive 4. So that's one way that we can express this answer. Another way we can express this is using a number line. So if we have 0, we have 4, and x is greater than 4, we can indicate that by doing an open circle above 4 and a right arrow to the right, indicating that all numbers to the right of 4 is a solution for x is greater than 4 that reveals a true statement. Similarly, for parentheses, we can say open parentheses 4, comma, positive infinity. So any number between 4 and positive infinity is going to be a correct answer. So note that if for some reason we had an answer that came to x is greater than or equal to 4, we can also express that by using a graph by simply just filling in that bubble at 4. So that means that all numbers to the right of 4 and including 4 is going to be a solution to x is greater than or equal to 4. And instead of doing a open parentheses, we'll do a closed parentheses, so 4, comma, infinity, and that indicates that 4 is also part of the solution set. Alright, let's do another example. One a little bit trickier. So negative 3 is less than 2x plus 3 less than or equal to 9. So we got two inequalities going on. So instead of, so if we have 2x plus 3, we're going to want to subtract 3 on all sides of the inequality. So we're going to add, we're going to do it minus 3 and one more time. So we're going to have minus 6 is less than 2x is less than or equal to 6. Once again, we're just going to divide by 2, but this time we're just dividing by 2 one more time. So we're going to get minus 3 is less than x, which is less than or equal to positive 3. So that's one way that we can express our answer. We're going to also, once again, express our answer using a number line. So 3, negative 3, 3. And we can do this by doing an open circle above negative 3, a closed circle above 3, and a line in between these two circles to indicate that any number that's between negative 3 and positive 3, including positive 3, is a solution to negative 3 is less than x, which is less than or equal to 3. Or we can express this answer using parentheses by doing negative 3, comma, 3, square bracket. Alright, let's deal with a common word problem that we might have. So let's look at this question. An all-day parking meter takes only dimes and quarters. If it contains 100 coins with a total value of $14.50, how many of each type of coin are there? So there's actually two bits of information here. We have 100 coins total. So I say D plus Q equals to 100, where D represents the total number of dimes and Q represents the total number of quarters. And we also know that there's $14.50 worth of coins. So 0.1 times the number of dimes plus 0.25, the number of quarters, is going to equal to $14.50. So we have what I say two equations, two unknowns, and we can solve for both unknowns. So from this first equation, D plus Q equals to 100, we know that D equals to 100 minus Q. We can then take this 100 minus Q and plug it in for this D in the second equation. So 0.1 times 100 minus Q, because that's what D equals to, plus 0.25 Q equals to $14.50. So that looks like something that we've already done for. Now we can just solve for Q. So we're going to distribute that 0.1 into that parentheses. So 0.1 times 100, 10. 0.1 times minus Q minus 0.1 Q plus 0.25 Q equals $14.50. Now we can combine our like terms, and we're going to get 10 plus 0.15 Q equals $14.50, or we get 0.15 Q equals to $4.50. If we take $4.50 divided by 0.15, we're going to get Q equals to 30. Now remember, Q plus D equals to 100. If Q equals to 30, that means D equals to 70. So there's 30 quarters and 70 dimes. Alright, let's look at another type of word problem. So the sale price in department stores are obtained by marking down the retail price by 15%. That is, the sale price is obtained by subtracting 15% of the retail price from the retail price. So that means that the department store sale price is equal to the retail store price minus 0.15 of the retail price. And I got that from this statement right here. That is, the sale price is obtained by subtracting 15% of the retail price from the retail price. So subtracting 15% of the retail price from the retail price gives us the department store sale price. So now that we got this nifty little equation, we can then deal with that first question that we got. A, what is the department store price of a hat that has a retail price of $60? So we can just plug in D equals to the retail price is 60 minus 0.5, 60 times 0.15 times 60. So D equals to 60 minus 0.15 times 60. I'm getting 9. So D equals to 60 minus 9, and I get $51. The department store sale price is going to be $51. All right. B, what is the retail price of a dress that has a sale price of $136? That's saying if the department store sale price is $136, what is the retail price? So once again, we plug in 136 for our D variable, and we want to solve for the retail store price. So we need to solve for R now. So we have R minus 0.15 R. To solve for R, we're going to have to factor out an R on that right-hand side of the equation. 1 minus 0.15. All I did was factor out an R from this term and this term. So 136 equals to R times 0.85. We can then divide both sides by 0.85. And we are going to get 136 divided by 0.85, plugged it into the calculator, and we get $160 equals to the retail store price. Alright, that does it for today.